Hey guys, this topic's video has to do with a couple students here, John and Kim, who wrote down two different functions that have the same rate of change. We know that John's function is represented by this table, has 3 data points in it. So the test taker would have to use the add arrow tool to make a line that, if it has the same rate of change, would be parallel to John's function, and it could be John's function as well. So I'm sure that's the answer to the problem here. But to kind of, if you're teaching this kind of concept, basically parallel lines, same rate of change, things like that, then, using the dynamic features of GeoGebra again could just make a interesting lecture, maybe. So, one angle I think that we could take this is, I'm going to just show you the regression capability. We only have 3 data points here. I'm sure that these are linear, since we're talking same rate of change. So that's not too exciting. We'll at least show you how to do a regression model. But then also, using the parallel line tool and moving a point up and down, basically our y-intercept, we can represent any, parallel line that's could be Kim's problem. And maybe you have your students come up with a problem of their own, or an equation of their own that would satisfy this. And so as students are giving you different examples and different equations, you can move your line around to represent their specific function. So let's, first of all, I'm just going to put these points in a spreadsheet and show you the regression tools. So we have -1, -5. So I got my spreadsheet already open here. If you don't, just go up to View and view your spreadsheet. So I'm just going to put our points in here. We had -1, -5. Then we had 1, -1, and 3, 3. So 1, -1, 3, 3. Okay, so there's John's data. So I'm going to just select all of his data here, and let's graph it first of all. So I'm going to turn on my axes and my grid lines. So this third toolbox, where it's create list, we're going to create list of points. Points look good, so I'm going to hit create, and there's one of them. So if you hold control down, you can click and drag your screen around. Whenever you hold control, it'll change your tool into move graphics. So anyways, I'm moving my graphics window around. Here's my 3 points. Those look pretty linear. So the regression tools, I'm going to select the data again in my spreadsheet. Now I'm going to go to the second toolbox here. This is our analysis toolbox. So I'm going to do a 2-variable regression analysis. This is our data. So I want to analyze it. And now the regression model is linear. So you could set yours to linear. So we got 2x minus 3. So we can, if you want to, you can also, now that we have our model there, this tool or option that kind of has that arrow pointing out. If you click on that, you can copy to graphics view, and it'll go ahead, and now I'm going to get out of here. It puts that line through there. There's our equation, 2x minus 3. So I'm going to zoom out a little bit. Now what I'm thinking you could do, for an example of a way to use this, maybe your students wrote their own equation. So you can put a point, and I'll change it, maybe green, a little bigger. Put a point on the y-axis that'll slide around. And now we can use the parallel line tool to be parallel to this line, same rate of change, right? And go through that point. So now we can just move our parallel line tool, and here's our line equation. So if we wanted, right now it's in standard form. By default, lines always come out to be in standard form in GeoGebra. But if you right click it, you can go to this equation, slope-intercept form, click on that, and it'll convert it. So now we can see, the equation of our next line, and we can match whatever students say. So anyways, a quick example of the regression area, and then also just kind of an idea of how we can use some some problem that seems simple, and yet we could take it into a GeoGebra conversation, which can create lots of concept too, and help with their visual reasoning. So anyways, I hope that made sense, guys. Take care.